First up, we have team from KIET. Please come on the stage and manage your presentation.
Akhil, Charu, and Kanan. I have one question for you. How many of you have been frustrated with those products which easily pays?
Yes, Aiki. This happens to me a lot. And honestly, it is very frustrating. But do you know what the root cause behind this? The root cause usually lies in the production, how the product was made. If there were some errors or defects during the production, it will cause such problems later.
So, Akhil, can we do anything about these problems?
Yes, we can do something. And the answer is artificial intelligence. AI, when integrated with production, can not just detect the problems, it can prevent it from ever happening. Imagine a world where the quality of products in us is unmatched. There are no unexpected breakdowns or downtimes in factories, and every product that comes out of the factory line is of the highest standards. This is exactly what AI is capable of doing today. But to better understand this, let's see how industries have evolved throughout centuries. Starting with Industry 1.0 using steam engines to power machine, to Industry 2.0 having mass production using electricity. Then Industry 3.0 with automation, and now Industry 4.0 with AI, data, and smart machines, which are changing the game of reliability and quality of products. But since the start, industries have faced issues. Let's take an example to better understand this. An example of automotive engine assembly line. Imagine a facility assembling internal combustion engines with automatic torque tools and robotic systems. But time to time, the company faces issues. Issues like torque inconsistencies, sensor equipment failures, and quality control gaps. These three I've mentioned are small problems, but later in stage, they can have a huge impact. They can cause reduced engine life, batch inconsistency, where some engines perform well while others don't, which overall leads to customer dissatisfaction and bad reputation on company's name. So solving these problems is crucial for long-term trust. But traditional methods only work after the problem appears. We need something smarter. This is exactly where AI starts in. In our example, AI can be used with torque sensors to detect real-time inconsistencies, and also AI can be used with computer vision to inspect the quality of the products.
So let me ask you all a question. Do you think AI works all by itself? No. AI basically it is powered by several core technologies such as big data gives it knowledge. Secondly, machine learning makes it intelligent. Cloud computing gives it speed, and cybersecurity keeps it safe. And what do you think makes the factory truly smart? There are three key components that make the factory truly smart, which are IoT, cloud computing, and cybersecurity. So IoT, what it basically does is it connects the machines to the smart sensors and IP addresses, allowing them to communicate, create intelligent and data-driven industries. Secondly, cloud computing ensures the smooth integration between all engineering, production, services, and supply chain. And with this huge amount of connectivity comes risk. That's where cybersecurity steps in. It helps to protect the system. So far, we have seen that AI is important, but there is something to consider. AI is important, we have seen this, but how AI actually works to make industry smarter and more reliable? Well, Sana, AI doesn't pop up magically on the production floor. It's basically connect all the core technology described by Charu in a single intelligent system known as AI-driven system architecture. Basically, there are several layers in it. Let's understand those layers first. So, the first layer is industrial IoT sensors. Basically, there are eyes and ears of production tools. Basically, they capture the critical data like temperature, vibration, pressure, etc. Let's consider an example. A semiconductor fabrication plant in which temperature sensor ensures lithography chamber stay at a precise temperature. On the other hand, high resolution camera instead for micro defects. Now, let's move forward to the second layer, which is data capture and processing layer, the nervous system. Basically, the data that was captured by sensors must be transmitted and processed rapidly. For that, we use the technologies like OpenQA, Open Platform Communication, Unified Architecture, or MQTT, Message String Telemetry Transfer. It basically transfers the data to the center servers, where the platforms like Apache Kafka and EW Furnaces handles millions of terabytes of data per second. The data which we are getting is not completely relevant, so we have to filter out the irrelevant data and not storing it. Well, we use algorithms like 𝐻𝐤𝐢𝐥𝐿 algorithm and other machine learning algorithms. Now, let's move forward to the most important layer, where artificial intelligence actually shines. So the layer is AI core, the brain of the factory. Basically, powerful AI models analyze the process data and forecast the failures before it's happened and allow planned maintenance and stop the unexpected downtime. But there are three main purposes in this. The first is predictive maintenance. Basically, predictive maintenance using algorithms like LSTM and GNU neural networks for finding the defect at a precise level. On next move, so that is computer vision. Basically, computer vision use the algorithms like DCNN using modules 𝐒𝐤𝐢𝐥𝐥 for detecting the defect at a precise level. Now, let's move to the reinforcement learning. Basically, artificial intelligence learns in this by doing the task. If it do the task in a right manner, it get rewarded. Otherwise, it get penalty. Let's consider an example. Consider the example of plasma engine machine, where if it able to control the speed and flow of the gas, it will get the reward, and it will not, then it get penalty. Now, let's move forward to the next layer, which is control and action layer, the muscle. Basically, once the AI core make decision, this layer execute the decision with the help of these steps. The first step is AI decision and rule validation. Second is confidence and safety check. Third is interlock and redundancy verification. Fourth is action execution. And fifth is feedback and continuous improvement. Now, let's move forward to the last but not the least layer, which is continuous feedback loop, the learning cycle. Basically, it's works similar as a human learn from its experience and mistake. In the same manner, artificial intelligence learn from its mistake and experience and enhance its capabilities. For example, error time of setup in the production system, its efficiency is 95%, but it will learn from its experience, mistakes, and its efficiency within 2 to 3 months reach up to 99.8%. The one thing which I can say from these layers, this artificial intelligence is creating a revolution in the manufacturing. It's making manufacturing sustainable and futuristic. We have seen that AI is important and how AI can be implemented. Let's move on to technologies which can enhance the impact of AI. First of all, this consists of data-driven decision making, which consists of it revolves around IoT, sensors, devices, and machines. Companies can make smart decisions using this. For example, if a machine is failed, the operator can be alerted in advance and prevent downtime. Second is agility and flexibility. Think of this like if a customer wants a sudden change in a product, the whole system reconfigure it without wasting time or resources. Next, we have supply chain integration. This is basically connecting suppliers, contributors, and manufacturers all at the same time. Next, after that, we have cybersecurity and data integrity. As Raghav already told us, that data is the most crucial part with AI. If the data is not secure, even the largest manufacturers are at risk of cyber security. Next, we have some more techniques to enhance the paper quality, which consists of quality management system. First of all, it has ISO 9001, which is an international quality standard. After that, we have Six Sigma, which is used to reduce defects, and remanufacturing, also used by Toyota manufacturing. After that, we have reliability tools like FLEA, faulty analysis, LTBA, MTBR. And we have statistical process control, which monitors charts and data to give us the best output in the minimum time and the maximum efficiency. Next, we have taken the case study of a company called BYD, Build Your Dreams, which was initially a local EV maker, and it get transformed into one of the global leading companies. The main problem that they faced were that there were millions of parts, thousands of suppliers. Because of that, they've got zero room for any error. So what they turned towards AI, and by predictive maintenance, vision-based quality checks, and smart production planning, they have reduced their downtime up to nearly 30%, which literally means that more cars should roll down without needing new lines. And their defect detection accuracy reached up to 95%. At the same time, their cost per unit reduced and boosting profit, while the prices remain competitive. So the impact was very clear. Next, we have future of production, Industry 5.0. So why have we moved from Industry 4.0 to Industry 5.0? Just because we have to give it some human touch. We have sending robots to do work like tedious and repetitive works with precision, while humans focus on work such as design, innovation, and personalization. So basically, Technology 5.0 focuses on balance, technology empowering humans and not replacing them. So the one thing we can say that artificial intelligence is empowering the manufacturing and production industry. So I am concluding our slide with a quote. Production powered by artificial intelligence, quality without compromise, reliability you can trust. These are the references, and now we are open for the questions. Thank you.
A wonderful slide you have presented. Would you let us know how many industries in India are using the AI technology in production and working on the Indian industry?
So there are several companies which are using. Here take example of Schneider Electric. That is company for the electric component. It is using it, and Siemens is also the part of it.
Yeah, many of the steel plants are also using it.
Yes, sir.
Nowadays, maximum industries are using it. Industry 4.0 has been started in many of the industries. To work on it, rest of the things are on.
So overall presentation was good.
Yes.
I think that this process makes your life even better. Why it is searching in the net and all that. So we got to know what all is there in the industry. Now, my question is to you: why you chose BYD? Why can't Maruti Suzuki or any Indian automobile manufacturer for your use cases which you have used?
So basically, BYD is a company was working on, you can say that, which is a rising company. It just entered in the multinational level, sir. And for a red company, how its growth happens, we want to show that. Because if we talk about Maruti Suzuki, Siemens, they are bank capital company, and BYD is just creating its impact on the market on the electric vehicle, which is now on the demand. So that's what the reason, sir, to introduce.
But the BYD for India is
Basically, BYD is a Chinese company, and it's not about China they are valuable, but we want to show that the underdog company gets also performed on international level by research in this technology.
There's a term which came in one of his slides called preventive maintenance.
Yes, sir.
Also, it didn't get screened. So, would one of you, the yellow law, the second year law,
Predictive maintenance is basically like if a machine is going to fail, the analysis मतलब मशीन में पीछे ही एनालिसिस हो जाता है तो वो आपको पहले ही बता देगी कि मशीन कब फेल होने वाली है. सो दैट फॉर एग्जांपल एक एयरप्लेन का इकोमा है, उसमें कोई छोटा सा क्रैक आता है तो वो आपको पहले ही इन्फॉर्म कर देगी दैट देयर इज अ सर्टेन क्रैक एंड द इंजीनियर्स कैन फिक्स बिफोर कोई एक्सीडेंट.
वो वहाँ है जो इन्फॉर्म कर देगी.
सेंसर्स होते हैं and they can algorithmically feed on the machine.
Have you heard a term called digital twin?
Yes, sir. Yes.
So I accepted in presentation that would have come in. Although all the characters please goes into it, your presentation had that.
So, sir, the terms that you use that like accurate, it is also
I know.
example of
Also,
distribution.
One last question: what are the areas of production reliability did AI certainly help you to improve? You did mention about defects. Okay, I did hear that. So, what are the other areas of production in which AI improves the reliability?
Sir, if I take a simple example at the most complicated work, the semiconductor sector, sir, in which a high precision is required to detect the defect in the material. And the artificial intelligence is working very well over there. With high precision, it accurately decide about the defects, sir.
Measuring the same part and recording different results. Or revert पाएगा because instruction data couldn't repress it. Sometimes the gauge is perfect, sometimes the weightage is. Just like a doctor with a thermometer. Both the tool and the person using it matters. That's where measurement system analysis comes in. It identifies variation from both instrument and the apparatus. So the data they rely on is consistent and dependable, saving time, cost, and frustration. A warm welcome to all the judges, faculties, and my dear fellow mates. We are the team ABS. My name is Anurag Ghaziabad with my team. I am Harsh Chaudhary.
I'm sir.
And I am Abdul Chaudhary.
You have brought up a great point. Trustworthiness of data is crucial, especially in the terms of production and manufacturing environment, where precision matters. When we talk about MSA, we are addressing the heart of trustworthiness. It evaluates accuracy, precision, and reliability of measurement system used to calculate the data. Say, two operators measuring a same shaft and recording different values. This is confusing itself. But how to ascertain the correctness of our data? This is where MSA comes in. The appraiser and the product being measured all are of equal importance and can cause error. But what type of errors?
Specifically, error in terms of accuracy and precision. Imagine an artist shooting arrows. He is supposed to hit the bullseye. If he happens, hit close to the center, the target, then he is accurate. Accuracy is about being correct. How close your measurement are to the true value. But if it's low, then it compensated as zero error in a missing instrument like Vernier caliper. These are established by calibration in certified labs like NABL. While on the other hand, that same archer hitting on the same spot repeatedly irrespective of the target, then he is precise. He sees and means consistently hitting on the same spot and hitting a tight cluster of hits.
I got you. Precision is about consistency. Right. So should your data be accurate or precise?
Essentially both, accurate and precise at the same time, because this will build trust in your data and you are measuring what you think you are measuring.
If the answer to your accuracy or bias error lies with calibration, then how to address precision? It is the consistency of repeatability and reproducibility, where repeatability stands for the variation in your measurement equipment, where it is also known as the same equipment, the same part to be measured, and with the same number of appraisers. While reproducibility is for the ability of appraiser to measure an instrument with the same instrument, with the same number, with the same product and different appraisers. So, To conduct reproducibility and repeatability, we conduct a study named gauge R&R, where gauge is the measurement instrument and R&R stands for repeatability and reproducibility.
For performing the study of gauge R&R, we had to calculate the value of E, equipment variation, assessing repeatability, and AB, appraiser variation for determining reproducibility. If the value of variation caused by both is less than 10%, then MSA is accepted. There's where NDC plays a big role. NDC is a number of distinct categories. It tells us about process shape. It tells how our measurement systems are differed by parts. It is calculated by ratio of part to part variation to measurement system variation. For example, if our camera has two shakes, it will show black and white color only. If our camera has 5 shakes, it will show much color. But if our camera has 10 shakes, it will show a clear image of our photo. Similarly, in NDC, if it is less than 2, it cannot trust the measurements. If it is between 2 to 4, it cannot diagnose the process. If it is greater than or equal to 5, it is good enough to monitor variation. If it is greater than or equal to 10, that it is excellent for fine-tune process improvement. For performing this study, first the appraisers are chosen. They should be the people who have experience of participating in such kind of study. Generally, the appraisers are chosen. In the Rolls-Royce case, they also chosen the appraiser, appraiser A, appraiser B, and appraiser C. The typical specification thickness of the C was from 1.00 mm to 1.20 mm, and the part average was ranging from 0.9 mm to 1.20 mm. Further, it is advisable to take measurement of 10 such parts for establishing the consistency in repeatability. Rolls-Royce did the same. Measurement of these 10 parts 3 times by every appraiser should be done by the same instrument. Sample of this data is shown in the slide. For calculating the value of equipment variation, by this formula, where R bar stands for the mean of the average of the range and P1 stands as a constant depending upon the number of trials we are taking. So the value of E comes out to the 0.0028. And for the appraiser variation, there is a formula where H bar difference stands as the difference between the maximum part average to the median part average, and K2 stands as a constant depending upon the number of appraiser we are taking, and NR is the product of number of trials and the number of parts, whose value comes out to be 0.003. By keeping these values in the formula of gauge R&R, the percentage variation of gauge R&R comes out to 11.5%, where the 8% of the variation was by the appraiser. After addressing this issue, technical training for the instrument for the appraiser was done. After training their appraiser, the gauge R&R analysis was done again and the variation was dropped to 8%, confirming that our system is good and fit for use.
So, that instrument that was used here was a high precision only, remember? But what if we use accept these for collecting data?
Yes, this exactly classifies our data into two categories. That is, at variable data, as selected, let's say a vernier telecom, and attribute data, which we can see with the video. Our appraiser is measuring the pitch of the bolt, detecting fast or quick in numerical values. But whatever type of data it will be, MSA is essential. Here is a sample command of attribute data which can detect fast or quick data.
Lately, when I was studying this topic, I found that a case study of Ford Motors, which were facing a hard issue in the scrap part into the engines. So, while I was studying this topic, I encountered that Ford was facing a recalibration issue in their equipments. When they conducted the MSA, they found that the problem was with their digital top range, and the precision, repeatability, and reproducibility were all contributing to a healthy MSA.
Wait, then why are you facing the issue?
they are facing the rejection issue because of the accuracy and calibration problem into the digital torque range. After that, they found that after recalibration, they found that the digital torque range value reduced up to 5% and the scrap rate also reduced to below 20%. So, which resulted into a high reliability and boost in the production and saving costs. This is how MSA helped for to become a global giant.
As we have covered the concept of LSA like gauge area, FTCI decision and LDC, we found that MSA plays essential role in invariable production in industries. To conclude, MSA ensures that
It ensures accurate, reliable measurement data, identifies and quantifies measurement errors, and confirms stability and consistency over time. It highlights improvements, calibration, and it reduces variation. It provides confident data for business conditions. In today's landscape, MSA isn't optional. It's essential for both competitive landscape and combining and maintaining customer trust. Thank you for your attention. We are open to questions.
The good presentation. I think you are very brief. There was not tracker was not there. Now, while you were discussing about certain measuring fish rates, etc., etc., you are not talked about how to handle that. See, any measuring equipment makes certain method of handling. Unless you do that, it is not going to give the accurate result. Some type of precautions, how to measure it, and how to put it back on the proper location. Because if you handle the equipments without any care, every time you take the reads, you will not get the correct values. So this is what I would like. Thanks.
What is NDC?
These are number of distinct categories.
What is it used for? And can you use an example?
Yes, if our buyer gets us two measurements for bolt, we will take this measurement between them for specific control lanes.
Okay. This whole measurement, precision, how do you feel overall Indian manufacturing industry is doing? Is it competitive in terms of employee precision equipment, manufacturing? How are you doing? Are we in 2 years country going down or at similar level? In case you have, what's your opinion or the term for that? As compared to like Germany, we know precision.
So they are in Indian companies. They are more for safety requirements, but they are improving their measurement systems so that their safety and measurements can both get affected.
Can you let us know something about calibration with IT or native units? Calculation of question or measuring instruments.
So let's suppose, as we mentioned, a data of vernier caliper in our equity. So if there is an example of calibration. If vernier caliper shows 0.00 exact mm, it is good to go. But it has any minimal zero error. So we add that calibration to the accurate. When we take a reading, we add that to our final reading to get the accurate results. And just let's take a rough example of calibration as we have seen the date bars. It at the use of time, sometimes it gets lose to weight. So we send to the industry to recalibrate it and fill some material into it which gets recalibrated.
Okay, good.
To everyone present here, a warm good afternoon to the juries present here. So, you all must be thinking, who is this guy standing here? And for what work is this scene present here? So I'm Ghaziabad, this is my team, Master Aditya and he is Zia. We are here to talk about a topic, quality transformation in the Indian manufacturing. So let me refrain a line from the most famous movie. एक पेन की निप से लेकर एक बैग की जिप तक सब कुछ manufactured. From the point of a pen to the chain of a bag, every single thing is manufactured. So let me tell you one thing, even nature is a manufacturer. But what does manufactures? Music. How? Have you all listened to chirping of the birds? Yes, I have. I think you also have also. So let's move on to all the topics that today we are going to talk about. So our agenda is why quality matters and where the Indian manufacturing industry stands today. Next are the challenges we have faced, the problems and solutions, the government schemes and etc. What are the driving policies and changes we are introducing here? And practical roadmaps and a case study of the most famous company we all have learned. Let's move on to why quality matters. So, quality isn't just a checkbox. It's a promise that we make our customers. As per a CEO or a head of a company, what are the best qualities that we need to get? And what are the main incentives that I need to receive? So, better quality is fewer reworks, happier customers, lower lifetime costs, and strong potential for exports. Yes, if I have a company, I'm not going to just make it to India or just stay in India. Yes, I want to go to the news world. I want to introduce it everywhere I can. Next is that a manufacturer. As manufacturers ship from mass production to customized products. We all need our own products, customized things. Even a simple cup. We know we have all received such kind of gifts as some contests or on birthdays where the cups are holding photos of our own or our families. For it, qualities that must be followed as company holders are that we need to be fast, we need to be data driven, and we need to be consistent. The last thing is, let's hop on to a little history. So, before 1991, we know we didn't have much technology, not much connections, and anything else in India. But still there was production. Still there was everything we need. But the quality was not at a top-notch level. Before 1991, there were competitions, but not so much. So, a little bit of local companies and SMEs some with each other, but we never got some such fine products at all. But after 1991, international competition began. The ISO certifications came in. The companies in India, like large OEMs and SMEs, started to follow TQM's Six Sigma lean production and everything they could. Now let's see the current state of India. Where is 𝐾𝐿? Let me tell you. On the year 2024-2025, Indian manufacturing, we hold this 17% of India's GDP. The sector is expected to scale up to $1 trillion, and $1 trillion is not a small number. It goes across from 90 lakh crores in the IRBs. The next thing we go on is strong sectors. Which sectors move us up to the scale, the money, the GDP, and everything. Mainly the sectors are automobile, pharmaceuticals, industries, textiles, electronics, and etc. Indian manufacturing PMI has well above always been approximately above 50. So what is PMI? PMI mostly stands for Purchasing Managers Index. It basically describes the health of a manufacturing company, and we always have kept it above 50. See, this is a graph that explains the manufacturing PMI rate from the year 2019 to 2024 and the defect reduction rate from 2019 to 2024.
So, hello everyone. From here now, I am going to talk about the challenges that we face in quality. So, firstly, so the main problem that we face are the fragmented SME sector, which is usually the market that are not organized or the market works independently. Most of the shops in the MSMEs are not organized in any way. We have limited automation and limited adaptation. So many companies still use manual labor and manual machineries. They do not use CNC and they do not have the digital tools such as digital vernier and etc. The workforce failure also exists where the employees and the labor do not know how to use the digital tools. Now the inconsistent supply chain standards are also caused by the fragmented SME sector. which is where the independent companies produce different quality of products that are not the same. Now, in drivers of quality transformation, I'm going to talk about the two main pillars, which are policy push and technology. In policy push, we are going to talk about Make in India, ZEB, which is zero effect, zero defect. So in it, the main motto is to reduce the defects and improve the quality, which is all a part of Make in India to improve our position in the global hub and increase our manufacturing exports in the first world countries. In PLI, product-led incentives are the financial aids and incentives provided to the manufacturing communities that provided quality products and in quantities. In BRS norms, which sums up all of these, is the Bureau of Indian Standards, which are the standards set that are to be met by exporting the products as certain quality standards. That is. In technology, Industry 4.0 or the fourth industry revolution, it includes of the Internet of Things, artificial intelligence, and robotics. As basically I've talked before, it is the use of digital tools and digital products to increase the quality of our products, reduce the time required. Now, I'm going to talk about the last, which is the product excellence. It includes Lean, Six Sigma, and the total maintenance TTM, which I'm going to talk about in the next slide, and the Kaizen. So Lean basically focuses on eliminating waste and creating flow. Six Kaizen is statistical data on our shop floor, which helps to reduce defects and variation that we have talked about in the main challenges in the first slide. In Kaizen is a Japanese philosophy that focuses on promoting small and iterative improvement in our manufacturing site. Involving all of these in our companies improves quality and reduces maintenance costs. Now, I just thought I'm going to talk about TPM after it. So TPM consists of total productive maintenance. Total is the overall manufacturing piece, which includes manpower coverage, the life cycle, the manual labor, etc. Productivity is maximized as I've uploaded in ZEBs. Zero accidents, zero defects, and zero breakdowns. In maintenance, as I've talked, maintenance basically covers repair and replacement of our machines, repairing the old age machine, replacing the old boiler carrier that has zero order defect.
Now I will present the case study of Maruti Suzuki. It is the biggest car company of India and it started with Suzuki from Japan and later it became famous as the People's Car Company. The first of this is affordability and later the other companies like Hyundai, Toyota and Honda came to India. That's when the real challenges faced by Maruti. Because people wanted better quality, more safety and parts that use less use. So, to resolve this issue, Maruti introduced Maruti production system in which they use Japanese method, which is Kaizen, which needs improving step by step. For this, they used to train their suppliers for the whole chain to work better. And they also adopted JIT, just in time, which means not keeping extra stock. They also added 5S method, which needs sort, separate order, shine, standardize, and sustain. They added robotics and machine in welding and painting. They used to check daily their quality products so their defect could be zero. So after improving in these fields, the Maruti production has improved 30% faster. This is the PMI graph of past years. You can see PMI is protein managing the index, in which you can see that in past years our index has been increased and the defect rate of Maruti had been decreased.
So now let's discuss the expected outcomes. So we know that we can improve better and better every time we try. But after applying all these incentives, schemes, government schemes, the help of everybody, we can do up to 6 to 12 months for the upcoming output cycle, and we can just make our production faster. Next comes the final takeaways. Quality transformation isn't just a single project. Guys, quality means collecting every single thing we can We have to be fast. We have to be consistent as much as we can. We have to know the best product we can. Now let's hop on to references and sources.
Now, in references and sources, as you all may have seen, most of the sources we used were from government websites, data et al., which are research papers of the highest credibility. Now, in conclusion, Indian manufacturing is evolving from cost sharing to quality to export our products to first world countries. Key enablers, policy supports, as we have talked about, Made in India, ZEBs. Now, an SED must focus on priority, design, quality. Government programs, as I talked, Made in India, ZED, Skill India, are driving adoption. The outcome, consistent, sustainable, export-ready manufacture where Made in India means trusted quality. Thank you, everyone.
Thank you.
Presentation was through. So I see there are three people, and your energy level was very high. You see, we are not performing there. Like it is not a drama or theater where you have to be. Oh, I don't like it. Yes, but I like the way you presented that this thing. Other two, I like that you have to stick to your subject line. That is more important than the overall creations. Secondly, the subject was quality, but I could see some revenue and some figures were coming up. Why was it?
Yes, sir.
Yeah, I am asking.
Sir, actually, we started revenue because we were talking about quality transformation. So from past to the present. In the past, it wasn't that much, but in the present, we are talking about like approx 1 trillion users in the upcoming year. So it is a big amount. And as we see, 1 trillion approximates to 93 lakhs crores. So the more the cost, the more the efficiency we have in our company, the more the government funds the normal MSMEs give us, the more we will be trying to become productive.
But how you can relate that quality versus the decrease in the sales and all that?
Sir, the main reason we added the graphs was because we were talking about the increase in revenue of the export department. So the better our quality is, the more our exports is in the first world countries. Yes, sir.
One more question. While we discuss about the quality, so we can see a lot of new comes in the paper. Sometimes Soreca is calling back their vehicle because of certain issues.
Yes.
Yes, sir.
So your presentation wasn't having that tested. Some cases like some steering issue, some brake failure issue. So those were code quality related issues. Yes. So where was the miss?
Sir, actually, we had a less amount of time. 10 minutes, according to me, are not enough for a presentation on the topic of quality transformation. Because it includes the government, private sectors, and SMEs that are particularly equipped to the micro and small medium-sized enterprises. So we have to get in detailed research for it. And the graph I showed was a purchaser's magic index graph. It basically had some lines which went long in the year, and the upcoming scale it went up. So that were the years it is much maximum issues of big failures and the other companies.
Okay, so what does KMI indicate?
So PMI, let's others answer. You're really dominating the answer in C. So it's.
So PMI means Purchasing Manager Index.
So what does it signify?
It signifies if the company's export has been above 50, it shows that the company.
Companies export above 50 is what?
So actually,
Sir, basically,
so it means that is like a company. It means like.
Okay.
oh yeah, the PMI, I hope 50 means. Sir, particularly, definitely one thing, you already know about it, but PMI, I don't know what's it, that's why I'm asking. Okay, so PMI includes everything from the employee that's working, there is a outcomes what we are getting, the products.
Actually, what does PNR above 50 means?
Sir, it actually needs the help of the manufacturing industry.
What does PMI signify?
Sir, I can't get to the name, that popular question, the really person.
So first of all, PMI does not signify there are lots of variables which go into PMI. It's more of an economic stuff in terms of looking at demand, supply, what is the status of the economy. Its correlation with quality is very, very distinct. So PMI and defect rate, it's not कि defect rate कम होगा तो PMI बढ़ जाएगा. There's very low causal relationship between the two. I hope you understand what the causal relationship. So this is not the correct graph to be looked at any kind of an outcome. Let's go back to the first slide on Indian manufacturing.
First, a second slide on Indian manufacturing, staple premium and tech.
This one. So 70% of India's GDP is manufacturing. Is it good or bad?
Sir, we are scale.
Good or bad? Say it's good. Answer is wrong. Okay. The sector is expected to scale up to $1 trillion, driven by policies. Okay. What is India's? What will be India's GDP 25-26?
Sir, it will be nearly 2.5 to 3 trillion.
You have already crossed 3 trillion. So let's say it will be 4 trillion. Let's say then 1 trillion makes it 25% of India's GDP. 1 by 4. So can the manufacturing its contribution to GDP increase directly from 17 to 25, jumping a year?
So it's expected, as I mentioned in the slide.
Who is expected 25%? Which government report? Which McKinsey? Which PCES? Where is the source of this data?
Sir, I think it was wrong.
Science of India and the Indian government.
Everything thinks it's wrong.
Okay.
Can you tell how IIT works in quality transformation?
IIT. Again, repeat the question, please.
How IIT working in the quality transformation? आपने IIT का कहीं तो चर्चा की? Yes, sir.
No. Okay.
Sir, I think the benefit of things IoT, I think it's related to artificial intelligence. Where the data of where the manufacturing things is used, to improve the workshop floor.
So basically, IoT contributes to Internet of Things. So quality, as I mentioned, it's not about just we are manufacturing something. We need the customers to be happy. So from the availability of any from India outside the world, we have ordered as we are using the web right now. We are using Internet. So according to me, IoT gains that it's easy available.
It's okay, but it was well decided by team. If you were, the answer is hidden there in that slide. So you.
Nice.
Thank you, sir.
Show the quality management system. The upper part shows the quality assurance and bottom part shows the quality control. Basically, the quality management system has two main components such as quality assurance and quality control. The quality assurance is also called as quality prevention method, and quality control is also called as quality detection method. In quality assurance, we can prevent the product by the root cause of defects, and in control we test the product and by the various method and convey the further processes. Now we move to Six Sigma. So initially the Six Sigma was introduced in early 1986 by the two American engineers, Mr. Bill Smith and Mr. Michael Harry. They both are worked in Motorola company, and initially the Six Sigma was implemented in Motorola company in early 1987. By the implementation of the Six Sigma in Motorola company, the Motorola company sales achieve a huge achievement. They sales around $15 billion as by the implementing of Six Sigma in their production and manufacturing process. So the Six Sigma, Six Sigma is the set of quality control tools and techniques that is used to eliminate the defects, variation in products, and also reduce the time consumption and also reduce the waste. So, and get more and more customer satisfaction towards to our product and their good feedback regarding our product. Now we further move to next line that shows the standard deviation graph of Six Sigma. So basically the Six Sigma have basically 6 levels: 1 Sigma, 2 Sigma, 5 Sigma, 4 Sigma, 5 Sigma, and 6 Sigma. 6 Sigma is the maximum level at which the defects are used around 3.4 ppm. ppm stands for part per million, and the yield percentage 99.99. And the Six Sigma at the lower level around 1 Sigma level at which the defects comes around 6,90,000 and the yield percentage is 30.8%. So next, like why we use Six Sigma? So Six Sigma is needed every education sector, in production sector, in healthcare section, everywhere the Six Sigma is needed. So why we use Six Sigma? The main point is that so for reducing the waste, for reducing the defect production, for reducing the time consumption, for increasing the sustainable development, for gain so much as more customer satisfaction and high quality product outcomes. And this is the histogram graph that shows the variation and standard deviation of Six Sigma level. The left side is show the lower significant level, and right side shows the upper significant level, and the upper histogram shows the 3 Sigma level, and lower graph shows the 6 Sigma level deviation. Now, Asad will tell you the further methodology of Six Sigma.
The important methodology of Six Sigma is DNAAC. DNAAC stands for Define, Method, Analyze, Improve, and Control. A define, identify the problem of our process. Then we set what are our goals, success criteria, and the target that they need to achieve as per the customer requirement. We set our goals in smart time for specific, measurable, attainable, relevant, and time-bounded. Tool views are voice of customer and quality personal deployment. Next comes measurement. In this step, we collect the data of our process, and we identify the standard metrics for them. And we use the measure system to assess the pattern and make assumptions about them. The tools used are measurement system analysis and 𝐒𝐤𝐢𝐥𝐥. Network analysis. In this, we find the root cause of our problem. The problem can be and create a new better problem. Can we take action? Can we actually help for them? And if should our goal be updated, the tools used are failure update analyzer and Fibon diagram. Next is improvement. In this, we find alternate solution for our problem or develop a new solution for our process so that we can reach our goals. The selection will be eradicate the impact and find what are the working consequences that happen due to our solution. The tool used are Kipelatic making Innova. Next, some control. In this, we collect data our new improved process and check if it is continuously improving and various functional results for our goal. The two data control chart and kind series methods. This is a block diagram of DNAAC. Then we identify the quantity, then measure the key outputs, then identify the critical inputs, actions, and optimize it so we get our right whites, our outputs. Then we can work again. So now is right there limitations of the Six Sigma. So first of all, this initial cost is very high. To if you are talking about a company which is working on the Six Sigma in the previous years, so applying the Six Sigma tools and the technology is going to be very costly. So first point is the high implementation from because of the training and the resources. After that, we have a point of culturalization because employees we move working in the working based on the Three Sigma is very resistant to apply their Six Sigma technology and resistant the new technology which is adopted by this company. After that, we have a complex tools, need a leadership, employee resistant, and industry fit. So after that, we have a slide of the application of the Six Sigma. So if we are talking about the application of the Six Sigma, basically the Six Sigma is for those industries where the manufacturing of the any product are going on. But if we are talking about the application of the Six Sigma can be used for the service and which company are going to design a new is which is called DNA ID method. So in this series we have a in which company we get some manufacturing parts. So first one take a manufacturing, second one is A&E and construction, third one is the finance, supply chain, healthcare. Because of why healthcare? Because in the healthcare we have some machines to measure the disease. So in the precise manner, in the if we are talking about the precisely accuracy of that machine should be high. Based on that, we have to take over some results. So after that, we have a case study of the company name is the 𝐋𝐤𝐢𝐥, actually Gurugram, India. So this company is manufactured rubber weather sheets. So first of all, in this the problem is showing the dimensional inconsistency and the surface imperfections. So which is directly lead to the material wastage. First of all, in the data, we can easily see 153 is per month wastage. After that, we are applying the Six Sigma technology. It is going to be 68 per month. This already invented by the 1995 and early Six Sigma technology is company in 2023. So after that, we have to slide off. In the present, what kind of the trends we are using Six Sigma? Basically, here talking about the AI and ML. So for the artificial intelligence, we are using the Six Sigma to reduce the downtime, increasing the efficiency of the machines. After that, we have some area in which we have also application of the Six Sigma, digital transformation, agile lean hybrid. If we are talking about the agile lean hybrid, there is some specification. Because we are doing some mining for a particular systems, so two problems are coming. First one is darkness, second one is the system for which we are doing mining. So we are applying a Six Sigma for those purpose. After that, we have a green Six Sigma for the heavyweight emissions. After that, remove entities and parent and governance. So this is all. Thank you, sir.
Content was good, but प्रिपरेशन आप लोग ऐसा है वैसे नहीं हम रट के आ रहे हैं अपनी स्क्रीन में सब कुछ लिखा हुआ है यू कैन लुक एट स्टूडेंट एंड लर्न द स्क्रीन आप लोग स्कूल में तो नहीं कर रहे हैं कॉलेज में है एंड अच्छा है सब्जेक्ट अच्छा था आप लोगों ने काफ़ी उसमें मटेरियल ही अच्छा था ओनली थिंग इन दैट अच्छी बात की जो एकदम आप लोग सोच के अंदर रख के बहुत सारी यदि गड़बड़ हो गया तो आप स्क्रीन को फॉलो ही इधर सो दैट इज इम्पोर्टेंट और आपने यूज किया तो दैट इज गुड दैट यू हैव गिवन द वन वीडियो फेस related to the Six Sigma and its benefits. Yeah, on the same.
Say in hospital, the healthcare sector which is using Six Sigma.
Sir, if we are talking about in the hospitalization area, we mostly use the Six Sigma. But the Six Sigma is going to be used in where the production laboratory are in the picture. So in the present, in which Six Sigma is using the hospitalization area, which is most commonly.
There is also a term called Lean Six Sigma.
Yes.
Never of them. So how is it different?
Sir, in 1985, the Six Sigma coming into the picture. After that, in 2000, Lean Six Sigma. What is Lean Six Sigma? It coming into the picture. Lean word for the output from the machine basically. If we are talking about the Sigma is the overall quality inherence basically. So when we are applying the Lean Six Sigma, it is the quality assurance overall the production department. So this is a Lean.
Okay, last question. You started very well in the presenting what is QMS, quality management system.
Yes, sir.
So where does Six Sigma fit into the quality management system?
Sir, if you are taking difference between the Six Sigma and the quality techniques, so the output getting by the
My question was, where does Six Sigma fit into the quality management system?
Sigma is part of quality management system. It is one of the techniques. Sigma specifically is a method where we have a goal, specific goal that we can 3 point for defect per area.
Thank you, sir.
Thank you so much, team.
Imagine a world where one side of the spacecraft was burning under the sun and the other side was peeling down. Yeah, it's a why it's answer right in the advanced material. Jerry everyone, we lucky KIET are presenting in front of you all to represent our topic of advanced material for spacecraft for harsh conditioning.
When we see a spacecraft, we see the cutting-edge technology. But behind that brilliance lies a constant battle with extreme environment conditions that a spacecraft sees. Within the Earth's atmosphere, there are various factors such as aerodynamic stress, temperature extremities, and these face challenges in the orbit can be the vacuum of space and launch and re-increase stress. Now, when it comes to the evolution, aluminum alloys form the backbone of the rockets like Sputnik 1. Then comes the titanium and steel that evolved in R7, and the Apollo 11 used phenolic resins that burn layer by layer, protecting the astronauts from the inferno of re-entry. For the first time, the materials weren't just a structure, they were these gardens of life. Then comes the carbon-carbon reinforced composites that was used in the Space Shuttle thermal protection system, and from today, their materials are smarter, stronger, and lighter than ever. The superalloys and carbon fiber composites are used. Well, after this evolution, there remain some limitations that require innovation. Some of them can be vulnerable to the micrometeorite impacts, low high temperature resistance, expensive and the single use of the materials, and they can be heavy and crack prone.
In the relentless of the processing boundary, the NASA had posed the new champion to the world of material science. 𝐿𝐤𝐤𝐥𝐿 A10, the alloy for the steel, also known as the nickel, cobalt, and the chromium, because of its symbolicity in the material, was developed by NASA in 2024. The A reason which caused NASA to develop GRX A10 alloy was the conventional material and their processing technique. This is the design of the combustor dome used in the jet turbine and the processing unit. With the development of the GRX A10 alloy, we develop a high ductile, a high tensile, and a material. Coming about its property, extreme temperature resistance. By the means of extreme temperature resistance are mean 1090 degrees Celsius and can also say 2000 Fahrenheit. Coming upon unmatched deep light, superior strength conductivity with the superior strength conductivity it will 1.3 kilopascal and the stable microstructure. Now coming up on the graph, on the x-axis we have temperature and on the y we have the tensile strength. Coming of the yellow side line we have the SVGRX. With the mean of the SVGRX it is the pre-manufactured GRX. Now easily we can see that the SVGRX is much more tempered than brown 625 which is represented by blue solid line. With HIP here was represented by solid yellow line with the mean of HIP, i.e. hot artificially and the process. With the mean of HIP is say that with the increase in the temperature its property increase. With Route 625 with by blue solid line, it has reverse spiritual line and unlike it can. With the high temperature is property degree. Now, I can easily say that the GI-810 alloy set the industry a booster in upcoming years.
Tesla. Tesla is not just a metal, it's a fundamental building block of modern systems. Tesla properties are high melting point. Tesla has a high melting point of 3017 degrees Celsius. A corrosion resistance. Tesla has one of the best corrosion resistance and it can resist almost all kinds of chemical reactions under temperature of 150 degrees Celsius. High density. Tesla is incredibly dense. It is dense as wide as C, excellent conductor of electricity. Tesla is a good conductor of electricity if the layer of oxide is on it acts as a dielectric. Now coming upon its applications, we have electronic capacitors and high temperature components. Electronic capacitors. The Tesla electronic capacitors are smaller and more reliable than other kind of capacitors. High temperature components, we have materials that were made from Teslas are used in rocket nozzles and thrust chambers.
Ceramic mixture composites, CMCs, are the advanced materials designed to withstand the extreme conditions where metals and polymers fail. They combine particles of matrix to overcome brittleness and maintain a high temperature capabilities and to have the super strength to weight ratio. The characteristics of CMCs can be the density, fuel efficiency, temperature capacities, and the weight reduction. And these all characteristics make it a promising element for the aerospace industry. Looking to the future, CMCs are helpful for hypersonic vehicles, space exploration systems, advanced turbine engines, and the reusable rocket components.
Imagine a metal that can bend and return back to its shape. These metals are known as smart memory alloys. The smart memory alloys have 4 key properties. First, the shape memory effect. Due to this property, it acts like a muscle which has a memory which can be programmed using heat. Super elasticity. Due to this, it acts like a metallic rubber band which can stretch and snap right back, making it durable. High damping capacity. It is a great shock absorber which can protect highly sensitive components from vibrations during a rocket launch. High power to weight ratio. With this, a lightweight assembly properly can do the work of big and heavy models, reducing total system mass. Now, let's see the applications. By using SLAs with its memory, we can make foldable solar panels and antennas. By using its lightweight strength, we can make gentle release mechanisms which are used in James Webb Telescope. We can also make actuators for latches and relief mechanisms. Now, let's talk about the global supply chain. The global supply chain has 3 parts: raw materials, processing and refining, and component fabrication. When we come to raw materials, the process begins at mine. Key elements like cobalt and tantalum are geographically concentrated, with a majority of world supply originating from a few specific regions. Second, processing and refining. After extraction, the raw materials are complexly refined. This is a specialized industrial process with significant portion of the global capacity centered in a single nation. Now let's move on to last step, component fabrication. With this, the refining metal is turned into highly specialized components, which requires specialized and high-tech facilities which are available in only a handful of countries with high sales advanced technology.
Now, coming to the key area and focus of the 4 different space agencies: ISRO, NASA, Roscosmos, and JAXA. ISRO focuses on the cost-effective composites, while NASA focuses on cutting-edge research and development. Roscosmos works with the flight program systems, and JAXA works on the lightweight structures. When we see the applications, ISRO work for the carbon composite for PSLV and the abbreviated heat shields for Gaganyaan. NASA worked on the carbon heat shields for the Parker solar probe. NASA's worked for Soyuz on the aluminium magnesium alloys, and the JAXA worked for hydrogen 2 with advanced composite materials.
Now, we are now going into the past to understand the marvel of modern engineering. The void of its CESA. We will not only explore its method, but the very period that allowed it to survive an epic age of 45 years. Launched in 1977, Voyager 1 initial mission was to explore Jupiter in Saturn, but its journey didn't end there. It became the first human-made object to enter the interstellar space, a testament to its incredible durability. Now coming up with its materials, its whole structure, we have used aluminium alloys, titanium and barium. For its thermal protection, we have used multi-layer insulation and board coating. To power it for light, we have used plutonium-238 and thermocouples. And last but not the least, for communication, we have used copper wire and radiation hardened components.
Now it's the time for the startup, the future of our industry. We have Pixel and the Biopics. Both are the Indian company and the Bangalore-based headquarters. With the Pixel, it was developed in 2019 and the Biopics was developed in 2015. With the Pixel mission, it has a setup of a satellite of about 2025 and satellite 2026. With the Biopics aerospace, it made a satellite of about a short range about 180 to 220 kilometers. With the references in the conclusion, the involvement of the space exploration is intensively linked to a material science. The next generation of material will pave the way for safer, longer, and more ambitious vision to the farthest reach of our universe. Thank you, everyone. Yeah. Your good thanks.
Nice. टाइटन मटेरियल के बारे में बात की है. So the 10 lakh capacity be used in power electronics.
Yes, sir. Those capacitors can be used in electronics.
I'm not asking electronics, power electronics.
Sir, thank you. Don't know.
What went wrong with the CSAT provide in the Natal?
So there are just pressure difference and the shear difference.
No, what exactly happened? The cause of that TSR?
So basically, in all guessing, the temperature and the pressure were inside, so it was compressed.
I'm guessing
No. So they saw global. Yeah.
Definitely.
And space companies you mentioned, why Tesla was not fair?
So basically, we are more focusing on our PR. It's and delegates our me from who we are.
Okay.
What will the considerations for this design firstly when developing materials for states? What will be the consideration we put publication into account while designing materials for space seas?
So for basically designing a material for space, we could be temperature resistant. It will be a more temperature resistant because in outer atmosphere there is structure like that. Basically, the structure like is what when you provide in pressure for a constant time and the temperature, the material get compressed, so it more has structure like.
Other considerations for design for developing materials.
For developing materials, fusion materials, you need to take temperature resistance into account. That's our resistance, high strength to weight ratio, low density, and free like high value.
Okay, so one suggestion why you very nicely explain various materials which are there, which I use. The presentation would have been much more strengthened by looking at what goes behind designing the material, what are the challenges of space, which the new materials need to overcome,
Your first slide, initial slide did mention 3 or 4 areas. It was really incomplete, those areas, but really is mentioned. But those parts were missed out completely. From a requirement of space, what are things which the designers of these materials need to focus on to meet the challenges that space provides? That's something it's probably to similar to you do next time. Those should come out a little more sharp.
Sure.
Thank you.
You mentioned 3D printing somewhere. They're carrying us really 3D keen in the rocket now. कभी कुछ डैमेज हो जाए तो बना के वहाँ ले जाना.
What's the role of Indian industry in all this?
GCTs are Baltic and Pixel. So Baltic is now worth about 200 crores and Pixel is about 299 crores. So they are doing good because they are collaborating with our issue. So in the supply chain also, the ISRO is focusing on self-reliant supply chain, focusing on developing its own materials, and government has also introduced many schemes which are space friendly, and the majority of this topic industry are also involved in space material, especially steel industry. Yes, sir. Yeah. So.
Thank you, sir.
Thank you.
Thank you so much, sir. Congratulations to Team KIET for securing first position.